Alright, so here's my free body diagram for the box. That's normal force, mg, for gravity, and this is going to be friction. Okay, now I went ahead and, N minus mg equals 0. Well, we would move mg over to the other side, and it's N equals mg. So the friction, that's mu Fn equals mu mg. I just substituted for N. That's N. And because N equals mg, I just said mu F mg. Okay, that's going to come into play later. So this is the equation, the conservation equation that I'm using. These two terms will not cancel, not the initials. Okay, we cannot set that to 0, either of them. But one of these final, on the final equation on one of these sides, it's going to have to cancel. So I chose the final. So I went ahead and chose this one. Okay. Now, so we know what the mass of the ball is. Okay, I went ahead and converted it 0.315 kilograms. We know the mass of the box, 3.54 kilograms. The initial velocity of the box is just 0. Okay, so obviously it's not gonna it doesn't have any momentum, and the velocity of the ball is 54.1 meters per second. Actually, this should be initial. So I know I messed that up, but that should be initial. So for the ball. So I went ahead and plugged it into the equation. So this is the ball. Okay. So this is going to be just the mass multiplied by its velocity. And then we're going to add that to the mass of the box and its velocity. But that whole term is just 0. So now, this right here, on this side, everything's gonna have to be final or total, I should say. At least in the case of mass, it has to be total. So I went ahead and added the masses, 0.315 kilograms plus 3.54 kilograms. That's 3.855 kilograms for both the ball and the box. So, and that's why I set it equal to that multiplied by V. So this right here is going to come out to be 17.04, and I just went ahead and divided it by this, okay, to get the velocity. So now the final velocity of both the ball and the box is 4.42 meters per second. Well, now this is the equation that I'm going to finish up with, okay? So we know what the final is. We know what the initial velocities are. We're trying to find out the distance, and we don't have the acceleration. So now to find out the acceleration, we go back to the free body diagram. So acceleration is going to be equal to the mu mg over the masses, the total mass. But the m's cancel. So now acceleration just equals mu g. So because of that, let's see. So that's the mu, and that's the g. So it's 6.99 meters per second squared. That's the acceleration. So now we can figure this equation out. Okay. Now, so we're trying to find out what the final, we're trying to find out what the distance is. But we know what the final velocity is. The initial velocity is already 0 anyway, right? Because this was right here, right? And it was just 0. So we can go ahead and say, okay, that's 0. Now, so the absolute final velocity was what we calculated, and that was this, 4.42 meters per second. So that's 4.42 meters per second squared over 2a, okay, 2 times the acceleration, and the distance is 1.4 meters traveled by both the ball and the box.